Good morning, my dear friends. Welcome back to my YouTube channel. Today I am going to discuss a Leetcode problem on March 10th. The problem is we should count the number of substrings containing every vowels and k constants. In this, they have said we should count the number of vowels present in the letter substring and k constants. They would be given the k constants. K is a string, K is a integer. They will be given a string of word. Let's see problem statement. Problem statement states that you are given a word W, a non-negative integer K. String of word of type string and K is of type int. First note down what are the types they have given. Next, we should return the total number of substrings of word that contains every vowels A, E, I, O, U, and at least one. Vowels given condition one is vowels should contain vowels at least once, at least once, and exactly k constants, exactly k constants, k constants. Here, instead of finding exactly k constant, we can also find at least k constants, at least k constants. That means it can have 0, 1 up to k number of constants. At least k plus 1 number of constants because they have said exactly k constants. We will find out up to k or k plus 1 number of constants. Let's see what is the approach to solve this problem. All of you know that if they give count the number of strings, we should what are the requirements? First we will note down the requirements required for this. Requirements. One, we should count the number of substrings. That means hash map is used because hash map is a data structure which keeps trace of the count of the maps in the string hash maps. Next, to trace the every vowels, to trace every vowels that is present in a hash map, we use the hash set. We use the hash set. Next, these are the requirements. Let's see one example. Example is what is the problem? How can we solve this problem is problem example is let's suppose example is A, E, I, O, Q, Q. Let's suppose K is equal to 1. For K is equal to 1, for statement in the string of word, it should contain all the vowels A, E, I, O, U. Listen, my dear friends, we should contain all the vowels in the string, and it can contain exactly one number, k number of constants. That means it should contain A, E, I, O, U. It should be guaranteedly appear in a substring. In substring, it should contain A, E, I, O, U. It can contain one number of constants. That is all the set of constants. It can contain only exactly one. Instead of finding exactly, I find at least. That means here we have one trick to solve this problem. The trick is, let's suppose it is a number line or the 0 to n number of strings. 0 to n number of strings. If we find from this to this is this, it is a first substring. This is the second substring. For finding at least, if we find the difference of length between 1 and 2, if we find the difference between 2 and 1 or 1 or 2, 1 or 2, we prefer this for positive. We prefer this for positive. This will be the approach. This will be the approach to solve this problem because we should subtract 1 from 2. So what is the approach? What is the approach for this problem? In the initial step, at first, we should keep track of the vowels. So we add all the vowel letters into hash set. All the vowel letters into hash set. First, initially, we add all the letters into the hash set. That means hash set contains A, E, E, I, O, U letters. Next, in the earlier classes, we have discussed about the sliding window concept. Sliding window, in which a particular substring of size will be moving. To reduce the complexity, we use sliding window algorithm. It is an algorithm. Let's see how can we solve this using sliding window. Third step, if the given string, substring, if suppose in an example A, E, I, O, U, Q, K is equal to 1. It is an example. Let's suppose this is a substring. This is the substring. Substring is a group of characters that are in sequence. It should be sequence. No, like it is a sequence of letters. So it can be called a substring. In this, if the current particular character is present in the hash set, we add in the hash map. Why hash map? To keep count of the letters that are present in the given word. To keep trace in the given word, we use hash map. This hash map is used to keep trace. If it is earlier present in it, we increment the value. Hash map contains key value pair. Key value pair. In the earlier classes, I have discussed clearly about hash map. If it is present, if it contains, we increment the value plus 1. If it does not contains, if hash map does not contains, if hash map does not contains, it is the condition 1, it is the condition 2. If hash map doesn't contains, we insert character in the hash map. Hash map is used to keep trace of the number of count. It is used to keep trace of the count in the word. Now, what is the next step? After this counting, if we reach the maximum size, that means we have reached the 5 vowels are present in this, and constants also C. C is represented by number of constants. Number of constants also reached up to the maximum, that is maximum. This has reached maximum. Then we increase the left pointer. That means in a sliding window, after reaching, it is similar to if we have reached similarly if we have reached to the maximum if we have reached to the maximum, we increment the left pointer. In similarly, if we have reached the size of the hash map, that means it contains the any number of vowels and it contains the constants. It contains the constant. We increment the left pointer. After we iterate through the hash map, step number 4 is we iterate through the word until right pointer is less than or equal to word dot length. I think all of you had know this basic functions like length, size, and many are there. Now it is the pseudocode. We have completed with this pseudocode. Let's see one example. The example is, let's see one example. Suppose the example is AEIOU. A is equal to 1. Suppose the example is word is equal to AEIOU. K is equal to 0. Word is 0. Now, what I have said in the initial step is to keep in the hash map. AE, add all the elements, that is vowels into the hash map. Let HS be the hash map. Hash set, sorry. Let HS be the hash set. Next, coming to the second point, we add the letters. Let's suppose A, E, I, O, U. Initially, left pointer is equal to 0, right pointer is equal to 0, answers, number of elements is equal to 0. We should return the answer in the form of long. So we initialize in the long of answer. Initially, no number of constants. Constants is equal to 0 and hash map. Let's suppose the hash map is this. Now, we check the element that is present in right. If it is vowel, we add into the hash map. If it is vowel, we add into the hash map. Next, we iterate to the next pointer, right. If it is vowel, we add into the hash map. E is equal to 1. Next, we iterate to the next pointer. Right, it is right, or to the next pointer. If it is caret, this particular index is vowel, then we insert it into the, or insert or put. It has the functions like put, get or by default. Hashmap contains the functions like put, which is used to insert the element, get, which is used to get the value of the element at particular key. Value at particular key. Get or default. Get or default. It is used to, if it is present in the, if it contains, it increments the value. Incrementing. It is an important function. It is important function, my dear friends. Remember, if it is present, it increments the value. If it does not contain, it inserts into the, it puts the value into the hash map. We have seen that it is the hash map in which it inserts into the, if it is vowel, then it inserts into the H map. Let HP be the hash map. Now coming to the next point, next right. If it is vowel, we insert into the hash map O of 1. Next, we increment the value to the right pointer. If it is vowel, then we increment. Given or after iterating through the hash map, if the hash map contains the size of element 5, that means all the vowels are present. Condition 1 is all the vowels are present and it does not contain more than the element. That means at least it should contain at least k number of elements. It is condition 1 and condition 2. If both the conditions are equal, we increment the left pointer to find out the next substrings. Because here A, E, I, O, U, this substring, it contains this substring also. After the increment of value to the left, it contains this substring is already calculated here. So we ignore this substring calculation and returns the value. Return the answer as 1. We increment the answer because we contain hash map contains 5 number of vowels and it contains at least k. Let us see if the answer is correct. So here you can see, my dear friends, The output is 1. We have got the answer. Let's go through the code. Let's go step by step how we solve this problem. At initially, we take a hash set of type character. It stores of type character. HS is equal to new hash set. It is the step 1. Next, we keep the vowels in the hash set. Hash set has a function called add. It a Now, suppose long a is equal to, it is a helper function which calls the other function word of k. We should find at least no. So we have find out get of word comma k plus 1. We should find the at least. We return of a minus b. Return of a minus b. Let me initialize the helper function get word comma int of k. In sliding window, what are the initial steps? Int left is equal to 0, int right is equal to 0, int answer is equal to 0. We should keep track of constants. Let constants be c is equal to 0, and we initialize hash map of type character comma integer. It is key value. It is key data type. It is value data type. It is key data type. It is value data type. Let hash map be HP. HP is equal to new hash map of type hash map of it. Now while right is less than word dot length. Word dot right is less than word dot length. We increment the right pointer. We see if the present value, let character at ch of right is equal to word dot character of, it is function which is used to get the character at the particular index. Right with the particular index. If it contains hash set, if the hash set contains this particular character, if it contains particular character, then we put character comma hp dot get or default. I have explained what this get or default in the before 3 minutes ago, 3 or 10 minutes, 5 minutes ago. Once check this hp dot get of default of character comma not character chr character. It gets the value. It puts the value if it doesn't contains in the hash set or hash map. Or if it is present, it increments the value to the +1. If it contains else, if it is the if hash map contains the if hash set contains the else, it would be the constant. So we increment the constant value. Now, if we have reached hp dot size double equal to 5, if we have reached size of 5 and constants, number of constants is greater than or equal to k. That means we have reached the maximum subarray size. Then Then we increment the long. Long is of type long is answer is of type long. Long. We subcast the integer value into the long. This answer is long data type. Long data type. Answer is equal, answer plus equal to long of. Due to time constraints, I will skip this code. I will now. I have already discussed how to write this code. I will come with. It is a long code, my dear friends. This is the code. In this, I have already discussed the pseudocode. I have implemented the same pseudocode is implemented here using Java. This is the code. Let us run the answer. Let's check. It is accepted. So this is the clear explanation of the today's problem. I hope all have understood this problem, and thank you. Subscribe to my YouTube channel and share with your friends. Thank you, my dear friends. Have a nice day. Thank you.